Some of us have a very good theoretical understanding of perspective, but when it comes to drawing real subject matter from observation, sometimes what we draw doesn't really look like what we're experiencing because we're over-relying on theoretical understanding. So today we're going to mix a little bit of theoretical understanding with a lot of observation to produce a drawing that looks convincing. And we're going to take a look at one-point perspective, which is a very simple approach to perspective. It presumes that you have, out of the three axes of lines that you would see in architecture, which would be a vertical axis, a width axis, and a depth axis, only one set of those lines is moving away from the viewer, the depth axis. The other two axes, the width axis and the vertical axis, are perpendicular to your line of vision. So you would always draw the width axis horizontally and the vertical axis vertically. So it simplifies things. So let's take a classic example now. First we're going to draw a horizon line. So we're assuming that we're standing on flat land and we're looking into the distance and we see the distant horizon. Prairies would be a good setting for this. And on this land surface is a railroad. So I'm going to draw one rail and the other rail, and these two rails are moving off into the distance. They get so far away, and that is quite far away because the horizon line is considered to be an infinite distance away from the viewer. They get so far away that that point on the horizon looks like they're actually touching each other. But in fact, those two lines or those two rails would never really touch each other. It's just that it's so far away that it looks like they're touching each other. So we have a vanishing point. That's an official term. We have a horizon line on which that vanishing point sits. We have two rails that are receding away into space and that appear to converge at infinity. And so we have essentially two of the three ingredients that we need when we're thinking about linear perspective. One of those ingredients is a vanishing point sitting on a horizon line. The other ingredient is a set of parallel lines. So these two rails are parallel to each other and they converge at the vanishing point. And the last ingredient is the presumption that there's a viewer looking at this who's in a fixed position, not moving around. Okay, we'll get to that viewer later. But for now, let's take a look at that railroad track. It's a little incomplete. We have to connect these two rails together, and we all know that the railway ties that rails sit on are those connecting elements. And so those are pieces of wood that connect that railway together all along its length. So let's draw the first railway here, the first railway tie horizontally. And we know now that we have to go to the next one and the next and the next. But the question is, how do we know where to draw those? Well, we could start with a simple way of conceptualizing this and presume that those railway ties are separated from each other by the same distance that the rails are apart from each other. In other words, they're separated from each other in such a way that they would produce a series of squares moving off into the distance. But of course, we're seeing this at an angle because this is a receding plane on which this sits. So we ask ourselves, well, where do we draw the top of that square? So when you're looking at a square at an angle, it won't look like what you know of a square. Because what you know of a square is, and this is a piece of paper that's approximately square, what you know of a square is that all sides of the square are equal, and so that's an intellectual understanding of a square that doesn't hold true when that square slants in space. So when that square slants in space to varying degrees, the vertical dimension gets compressed, okay? The width stays the same. So that's important to keep in mind because what a lot of people do when they're asked to draw a square seen in perspective is they could draw a line like that. And the reason why they would draw a line like that is because their intellectual understanding of a square forces them to put this line too high, because one feels that if this is one side of the square, and if you were to rotate this down, it should more or less equal the height. But that doesn't take into account that the square is seen at an angle. It's foreshortened. So that dimension, the depth dimension, is reduced or compressed. So this is not a correct way to draw a square seen in perspective. Perhaps a proportion like this would be more reliable and faithful to what you're actually seeing. Now, how would you know this? Well, if you're looking at a square in perspective and you're able to observe this and compare how high it is, if I draw a little dotted line here and here, this would represent the height of that back edge of the square, and you were to compare that to the width of the square at its base, you could say that that measure fits in 3 times. Now, it just so happens that that's what I drew. But let's say that's what you were observing. That's what you would draw. You would be faithful to what you were seeing if you were to measure, even with your thumb held out at arm's length. You could measure the height of that square and then see how many times that height unit fit into its width. And if you determined that it was 3 times as wide compared to its height, that's what you would draw. So now, before we attempt to draw the next railroad ties in succession, one after the other, let's imagine that we're floating above this railway and we're seeing this directly from above straight down. And we're going to look at a method for how to construct a series of squares one after the other. First, doing it the easy way, which is seeing it from above. So this square, as seen from above, would appear to be a true square and would look something like that. So how do we then derive the next square, apart from actually physically measuring it? Well, we could use some geometry. And if we look at the 2 ends of the top side of that square and we divide that in half, and we draw a diagonal line from the lower left-hand corner of that square and proceed up, it intersects the right railway tie, the right rail at a certain point. And when you're looking at this, if you're visually inclined, you'll realize that this triangle here is essentially just a rotated version of this triangle. They're both identical to each other. They're both right-angled triangles. They both have the same angle here. So it follows that if this unit is the same as that unit, and if this is the same angle, and these lines are parallel to each other, it follows that this measure equals this measure. So therefore, when you draw a line back from that point, you'll see that you've replicated the first square with another square. Now, if you divide this in half and you draw another line connecting that and going eventually to meet that right rail, you'll see that you could create another square and repeat that action to create another square and another square and another square. So instead of bisecting this line every time to save yourself some work, you could just use this first line and this line as a model and draw a dotted line up. And that dotted line, if it's straight, would forever bisect all subsequent railway ties. So you have yourself a method for how to draw squares in perspective. So when you look at this, you come back to this example. I'm going to divide this in half. I'm just doing this visually. I see both points here, so I'm able to visually judge where the halfway point is. I'm going to draw my diagonal line, and it intersects the right rail here, and I'm going to draw a horizontal back, and so on. We're going to bisect this just like we did with our top view example. I'm just going to complete that quickly. Just kind of faking it because I don't want to take too long to do the demonstration. And so there we have our railway looking quite convincing, moving away into the distance. Now, if you have a twin, and that twin was standing on the railway tracks looking into the distance, that twin, of course being a twin, would be the same height as you. And so if they were standing in this location, they could look something like this. Stylized representation of a human. And since your twin is the same height as you, their eye level is the same as your eye level. And since when you look to the horizon line is neither above or below, it's straight ahead, it's also at eye level. Therefore, it holds true that the eye level of your twin is exactly the level of the horizon line. So the horizon line is at eye level. We're going to use these basic principles to draw a one-point perspective drawing of a corridor with a tile pattern that makes use of this trick of drawing diagonal lines to create believable squares receding away into the distance. And also, just as an added effect, we're going to use some varying line thickness in order to create the illusion or to enhance the illusion that we're moving into depth. Let's take a look.